Hey there, I'm Lucas, and today I want to talk about the PowerXND 2000, which is basically a variable ND filter made by a company called Aurora Aperture in the sunny state of California. I actually think at this point in time, nearly everybody already knows why we would want and why we would need such a filter. So basically the function is that we have a filter consisting of two parts, rotatable, like against each other, and while we rotate it, we dim it down. So basically we have a variable dimming of the light that comes through and hits our sensor. So the reason why we might actually want something like this is that when we have a really bright light source, for example the sun on a bright summer day, and we want to have our aperture fairly wide open to get that nice shallow depth of field, and we have our ISO down, and then we are totally overexposed. Simple as that. So there's too much light, and then we would have to crank down our shutter speed all the way to 1/1000th of a second, 1/4000th of a second to get a proper aperture. The problem with this is that we then are left with no blur in our footage anymore. So we have no motion blur, and that feels really unnatural and really uncomfortable. Then we would use a filter like this, get proper exposure with the right aperture, the right ISO, and the right shutter speed. I reviewed ND faders before, very cheap, affordable ones, which did a fairly good job. So what is so special about the PowerXND 2000? So the first and literally biggest difference between, for example, the PowerXND 2000 and the Vodka that I reviewed earlier is the amount of light that you can block. It's not written on the packaging, but the Vodka has a range of 2 up to 400. While it's printed here on the PowerXND 2000 case, this ranges from 16 up to 2000. So what the heck do these numbers mean? Actually, it's quite simple and just involves a little bit of math. So basically, these numbers become the divisor for our light. So basically, our base light is 1. And this ND fader, therefore, will give us 1/16th up to 1/2000th of the amount of light. While these numbers make perfect sense, in film and video work it's a bit arbitrary, and we usually talk about stops. So the Vodka lets through at least half the light. So basically this is one stop, because one stop is always half the light. And the end of the fader is around 8.5 stops. The PowerXND, on the other hand, ranges from 4 stops up to 11 stops of light. And this is a tremendous amount of light. So in comparison, this does not sound too much, 8.5 versus 11 stops of light. However, one thing that we always have to consider, especially with the cheap ND fader, is that the maximum volume that we get out of our light usually introduces some weird sort of vignetting or artifacting. The PowerXND, of course, may have the same issue, and we get to this in a bit, but you can fairly assume that you can at least use 10 stops of light loss with this filter. And how much is 10 stops of light? This is actually a tremendous amount of light. Imagine you had a lens with an aperture of f1. So basically it's extremely sensitive to light. And when you would stop this down all the way to f32, this is 10 stops. I don't even think there is a lens which is capable of that. Let's have 1 second of exposure time versus 1/1000th of a second exposure time. This is 10 stops, and this is a tremendous amount of light. So the PowerXND is fairly slim for an ND fader. It's built really well, so the fading is very smooth and has a nice finish. So the biggest question that I always receive for ND faders is two things, which is basically the tint, because nearly every ND fader and filter will tint our image to some degrees, and the sharpness when I use this filter. The Vodka was heavily criticized, especially on the sharpness part, basically because it does not perform very well in long focal lengths. So basically anything over 70 or 80 millimeter will turn out very blurry and not very sharp when you use the Vodka filter. For some this is not a big issue. On wide angles it's not that bad. I guess now it's time to find out how the PowerXND performed for tint and sharpness. So what you can see here is the readout of my reference lamp. It's not perfectly balanced, so it's a bit less blue, a bit more red, but it's fairly neutral. You can see it's a pretty big light output. As soon as I hold the filter in front, you can see how the levels change and we get more blue coming through. So we are not that neutral anymore, but you can also see the amount of light that goes away, and this is really a huge amount of light. And I can't remember which setting this is exactly. What I can tell you though is that this tint is the same for all settings. This matches with what we can see in the actual footage shot with the filter, where red is more or less the same, but we have raised levels in green as well as in blue. This example was shot on a 200mm lens, which is also the reason why it's a bit shaky. I'm sorry for that. And what we can clearly see is how well the PowerXND performs in terms of sharpness compared to the image without any filter. However, what we can also see is how soft and somehow unusable the vodka turns out at this focal length. Looking at an ISO chart, we can get the same impression where at least the minimum setting and the version without filter have virtually no difference in them. However, when we pull the filter further to take out 10 stops or the maximum amount of light, we can see a very slight decreasing in sharpness. I must admit, especially the sharpness comparison blew me away a bit, because it performs just so much better against, for example, the vodka, and is nearly indistinguishable from the shots without any filter on, which is pretty cool. The tint, however, is way more severe, not only against the vodka, but especially against the footage without any filter. But we should not be too harsh with this. On set, you could easily get your white balance down by a few hundred Kelvin and compensate for that. And even in post, depending on the lighting you have, you can easily filter out that amount of blue. It's not too bad, it's not too hard, but still something we have to consider and have to know up front. What I found really interesting is the inconsistency of the max setting, because sometimes I got these really bizarre vignettes from the sides into the image, and sometimes I didn't get them. And it didn't even matter, because sometimes I got them from artificial lighting in my testings, and sometimes I got them from sunshine in my tests. However, in some scenarios I didn't receive it. For example, on the ISO chart, I did not receive these kind of vignette into my footage, and I have no idea why this is. So basically, I would not suggest using the max setting, because it can be a bit of a gamble from time to time. But like I said in the beginning of the video, you can easily get 10 stops of light out of your footage, which is still a tremendous amount of light, and this is a pretty safe setting. And I would always call to be better safe than sorry. So what is the advantage of this filter, which takes out a tremendously amount of light compared to a normal ND fader? So the vodka starts at 1 stop of light to take out. And usually I never use the vodka on this setting, because it's still a lot of light that goes out. It's half the light that passes through. Still, I usually need a bit more than that. However, on the other hand, 4 stops is already a bit much in some circumstances as the minimum value. So to me, the biggest advantage is to have the additional range in the end of the spectrum to take out more light. For example, if I wanted to use my A7S here and I want to shoot in S-Log 2, which has a base ISO of 3200. So I have to set the aperture to at least 3200 to get a shot. Now I maybe attach my f1.2 lens and want to shoot wide open, because I really want that shallow depth of field. But maybe now I'm also using a speed booster here to get less off-rolling shutter while shooting in the APS-C mode of this camera. So basically I'm also adding another stop of light, and suddenly 5 stops of light loss is not a lot, and such a filter comes increasingly helpful. But of course there are other helpful scenarios. For example, if you're a hybrid shooter and you also shoot a lot of photography and not only video. For photography, it's very interesting to have long exposures to get light streaks from cars, or you have like this floating swamp of water when you expose a waterfall really long. These are things that you only get with a really decent and down blackening ND filter. And why not combine that with an ND fader that you use either way when you are out in the sunshine? But even if you only want to have one filter in your set, I would still recommend to have a stronger one, simply because you can also always compensate with the ISO, which is usually all the way down when we use an ND filter. But we can crank it up just a little bit. It will introduce a bit of noise, but still more useful when you need the end of the range of this filter. So thank you very much for watching. I hope you enjoyed this, and I see you next time. Bye.